Okay, I made a video about electrolytic cells. I made a video about voltaic and galvanic cells. But sometimes it's helpful to kind of see that information together, mesh together. So that's what this video is going to do. Take that information and combine it so that you can easily see a comparison between the two. All right, so there are two types of electrochemical cells. We have electrolytic and we have voltaic or galvanic. Okay, the easiest way to tell the difference is look for a battery or a power source. Do you see a battery source? Electrolytic. Power source, electrolytic. No power source, voltaic or galvanic. All right, so let's get started. So we're going to compare them. So we're going to keep it the same in every slide. So the electrolytic cell will always be on the left side. The galvanic or voltaic will always be on the right side. So in both of them, it's a redox reaction. So we have reduction happening and we have oxidation happening. So we have electrons moving around. An electrolytic cell is not spontaneous. It's forced. How do I force it? With a battery. And galvanic or voltaic is spontaneous. It just happens. So an electrolytic cell needs a battery to force it. A galvanic or voltaic cell is literally a battery. Now, it may have a voltmeter, it may have something else in the circuit, but what it will not have is a battery, a power source, a source of voltage, a source of current, nothing like that. A galvanic or voltaic cell is literally a battery. An electrolytic cell needs a battery to force it. In an electrolytic cell and a voltaic cell, the energy change is different. In an electrolytic cell, it changes from electrical to chemical, and in galvanic or voltaic, it's the opposite, chemical to electrical. In an electrolytic cell and a voltaic cell, doesn't matter, the electrons always flow through the wire from anode to cathode. 100% of the time, electrons flow anode to cathode through the wire. In both of them, I need an electrolyte. So I need a liquid. Remember, an electrolyte is an acid, a base, or a salt dissolved in water. Most often we're going to use a salt, but it just needs to be an electrolyte that can participate in the reaction. An electrolytic cell might have a salt bridge, it might not. So having one is not excluded, okay? The ions are able to flow simply through the electrolyte. So see right here, the ions can just kind of flow around in here because they're in the same container. In a galvanic or voltaic cell, we absolutely need a salt bridge. And what is the purpose of a salt bridge when it's there? It is for the ions to flow back and forth to keep the cell neutral, okay? Now, the anode. In a galvanic or voltaic cell, the anode is negative, like an anion. In an electrolytic cell, that battery is like, I don't think so, and the anode switches. It becomes positive. Everything else about the anode stays the same. It's where oxidation happens. It loses electrons. You put electrons on the product side. The mass or the atoms decreases because you're losing electrons, and the ions in solution are going to increase. Here's the other change. So remember, force it. So the anode becomes positive. And so what happens, why that happens, is because on table J, the element that is higher in a galvanic or voltaic cell is the one that is oxidized. So if I look, I have Cu and I have Ag, right? Cu is higher. So you can see Cu is the anode. This is a voltaic cell. Now you can see I still have silver and copper, right? But this time, silver becomes the anode. It's the lower one, okay? So those are the two changes, really. The anode changes charge because it swaps locations on table J. So the cathode, just like the anode similarly, Galvanic, voltaic, the cathode is positive like a cation, but in an electrolytic cell, the battery forced it to be negative. But everything else stays the same. There's reduction happening at the cathode, gaining electrons. The electrons are on the reactant side. Because we're gaining electrons, the mass, the number of atoms increases and the number of ions decreases. But because of that battery, okay, the metal is lower when we're talking about galvanic and voltaic and higher when we're talking about electrolytic. So that battery forces two things: the location on table J to swap and the charge. Everything else stays the same. Okay, so there's an overview, a quick comparison, a quick review of the two types of electrochemical cells, electrolytic and galvanic and voltaic. I hope you learned something new.